All right, so the next thing we're going to go over is percent error. So what this does essentially tells us how close we were to the actual or the already measured value. It tells us how accurate we were in our measurements and in our formula. So a couple things you're going to need for this. You're going to need to know the formula, and you're also going to need to know two of the different variables. Your expected value, that means the one that you hypothesized or you thought would be the answer, or the one that you measured with your experiment, and your actual value. And so that is either what actually happened or what scientifically is proven. And so with this, I did a small experiment. I had an expected value with my dog. I thought, how long can she hold a treat on her nose before she loses all control and has to eat it? And so my expected value was 10 seconds. Her actual value of holding on her nose before she ate it was 13 seconds. And so I write down my K for KFMA, my known. So my VE, or my value expected, was 10 seconds. My VA, or my value actual, was 13. So next thing I do, I put down my formula. I'm doing this so I make sure that I remember what my formula is. I don't mix anything up. So I have my formula written down, and so I then plug in my M, my math. And so you can see these are color-coded. My VE, my value expected, was 10 seconds. That's how long I thought she'd be able to hold the treat on her nose. But I was wrong. Her value her value actual was 13 seconds. Alright, now you have that on top and on bottom, like the formula says. You'll notice on either side of the top of the line, you have two bars going up and down vertically. What this is actually looking for is looking for the absolute value, and so you're not going to have any negatives here. So instead of saying 10 minus 3 is negative 3, the absolute value of negative 3, meaning how far is 3 away from 0, is actually just the number 3. And so the absolute value of 10 minus 13 is 3, so 3 over 13. I could write my math underneath. That would be about 0.23. And then what I do is I times this number by 100. We're trying to get a percent. So 0.23 times 100, I'm going to move my decimal place over 2. And my percent error of how long she would keep a treat on her nose was 23 seconds. And so with this, make sure that you write down your units and then cancel them out. Also make sure when you're doing your math, you make sure you give the absolute value of a number, making sure to not have any negative there. So if it ends up being like 10 minus 3 and it's a negative 3 is your answer, just make it 3, because when you're looking for an absolute value is how far that number is away from 0. It's 3 spots away. So 3 over 13, so 3 divided by 13, that's 0.23, all right? 0.23 times 100, 23%. All right, so that is our percent error for this. I hope that helps.